In this lesson we're going to continue with the topic of vectors and we're going to look at the dot product, and this is the first in a series of 2 videos on the dot product. Now the dot product can be thought of as directional multiplication, so we have to keep in our head all the time that vectors have both magnitude and direction, and therefore they are said to have directional growth. So the dot product, as I've said, is directional multiplication. And multiplying 2 vectors means that we're applying the directional growth of one vector to another. And the result is how much stronger we have made the original vector. So while we're multiplying 2 vectors together, our result will actually be a scalar. Okay, it will be a constant. So just be aware of that as we go through here. So the final result of the dot product process can be 0. There might be no growth in the original direction. It might be positive, where there's some growth in the original direction. Or it might be negative, where there's obviously negative growth in the original direction, or the growth has been reversed. So we denote the dot product, or the scalar product as it's sometimes known, as A dot B. And this can be calculated as follows. From a rectangular perspective, A dot B is equal to A1B1 plus A2B2 plus A3B3, where vector A is equal to A1, A2, A3, and vector B is equal to B1, B2, B3. So you can see here what's happened is the X components have been combined and multiplied, the Y components have been combined and multiplied, and the Z components have been combined and multiplied as well. And it's then the sum of all of those products, and that tells us what the directional growth is in the original direction. Now we can also look at the dot product from a polar perspective as well in space. A dot B is equal to the magnitude of A multiplied by the magnitude of B multiplied by cos theta, where theta is the angle between vectors A and B. So in this video we're going to concentrate on the rectangular perspective of the dot product, and in the next video we will concentrate on the polar perspective of the dot product. So just a picture of what's going on here. Okay, say we've got 2 vectors, we'll call the red vector vector A and the blue vector vector B. And for the purposes of drawing this, these are 2D vectors. So we can see how vectors A and B have been made up using their components in the X and Y directions. And what we're going to do is combine each of the components of A with each component of B. i.e., we are mutating the original vector based on the rules of the second vector. And then the result, you can see it's similar to above. The result is how much push in each direction one vector is giving to the other. So let's have a look at an example. And the first example asks us to find P dot Q, given that P is 1, 2, negative 3, and Q is 2, 2, 3. So remember, the dot product combines like components. So our X components, Y components, and Z components. So we find the products of each of these and then we sum these products. So that's 1 multiplied by 2, plus 2 multiplied by 2, plus negative 3 multiplied by 3. That gives us 2 plus 4 plus negative 9, which when we carry out that sum, we get negative 3. So that is a reverse growth of 3 in the original direction of P. So just now would be a good time to pause the video and take this example down in your notes before coming back for example 2. Okay, welcome back folks. So example 2, if A is the point 239, B is 1, 4, negative 2, and C is negative 1, 3, negative 6, calculate AB dot AC. So as you might have guessed, we need to find the vectors AB and AC first. So AB, remember, is position vector B minus position vector A, and that's 1, 4, negative 2 minus 2, 3, 9. That means the vector AB is equal to negative 1, 1, negative 11. Now for vector AC, and that's equal to position vector C minus position vector A. And that's negative 1, 3, negative 6 minus 2, 3, 9. Giving us vector AC, negative 3, 0, negative 15. We now have all the information we need to find the dot product. So AB dot AC is equal to, and remember we're combining the x components, we're finding the product of those, and summing that to the product of the y components, and summing that to the product of the z components. So we've got negative 1 times negative 3, plus 1 times 0, plus negative 11 times negative 15. That gives us 3 plus 0 plus 165. So the dot product of AB dot AC is 168, which means we have a growth of 168 in the original direction of vector AB. So just now it would be a good time to pause the video before the screen goes blank, copy these notes down and complete the assigned exercise for today.